Greetings, this is Ms. Jackson. I wanted to make a video covering the page 56 extra practice that was sent home. It's part of the Lesson 4 homework. In Lesson 4, we move to looking at measuring weight. And we're looking specifically at the metric unit of grams and all the variation of grams that we find. Gram is not a completely new unit of measurement for us. We used it in science earlier in the year when we were looking at the mass of objects as one way to describe an object. We're going to get a little bit more in depth with grams and weight today. I wanted to show you, though, very quickly a couple of resources that we have. On the third grade math website, you will see this on the home page, STAR Grade 3 Mathematics Reference Materials. When you open this, you're going to see a copy of what the students are given on the STAR test to use as an aid. They're given a hard copy of this, and then they can also access it digitally on the actual testing interface. We'll go over more on how to use this in other videos, and we will go over it a lot in class. I also printed out a copy to put in each student's binder, so they should have that in a clear sleeve somewhere in their binder to keep for the year to reference it in class as we use it. Another tool that I want to show you is this polypad. To get to the polypad, I always go to mathagon.org. That's how I originally met the polypad, was through Mathagon. Mathagon has, I guess, been purchased or transitioned to Amplify, but it's going to work the same way. You can go to mathagon.org. I love this website for a million reasons. The polypad is just one. So if you click Launch Polypad, it's going to bring you to this. Kids love to just get on the polypad and play. There are amazing free resources and manipulatives embedded within this polypad. There are also games that students can use, probability and data things that they can use. I'm going to look today specifically at a pan balance. I just want to show kind of what that's going to look like. This is listed as a balance scale. It's going to be about the same thing as we're using as a pan balance. So I just wanted to show kind of what that looks like here. Let's go back to the actual page though. At the top, we're given a chart to help us find answers. And on that chart, I can see that we have some labels here: 1 kilogram, 10 grams, 100 grams, 10 grams, and 1 gram. We're going to use this information to answer the following parts of this. One thing I want to point out is in third grade, our question may have many parts to it. As you can see, we have a part A, a part B, a part C, and a part D. We have to answer all 4 parts. A, B, C, and D on problem 1 here are not answer choices. They are parts of the same problem. I could say this till I'm blue in the face, and I'm still going to have students that look at this and circle this and turn it in. A, B, C, and D are not answer choices here. They are all individual, unique, special parts of the problem that need to be answered. So please read carefully what's being asked to determine, is that an answer choice or is that something I need to answer? And if you need to answer it, you do not have a choice. A. Let's look at part A. Isaiah puts a 10-gram weight on a pan balance. How many 1-gram weights does he need to balance the scale? Well, you can draw a little pan balance here. If he puts a 10-pound weight over here, and we want this thing to stay balanced, we need to find a way to put an equivalent amount of weight on the other side. If I'm using 1-gram weights, I'm going to need 10 of those. Because 1 plus 1 plus 1 plus 1 plus 1 plus 1, 1, 1, 1, 1, 10 ones is going to give me a total of 10 grams. So he's going to need 10 of the 1-gram weights to balance the scale. Balance means to make it even all the way across. If we don't have 10 1-gram weights, it's going to look something like this. It's off balance now. Whatever weight we put on one side, we have to have an equivalent amount of weight on the other side to keep it balanced and to keep it even all the way across. As soon as we take off this weight, we're not balanced anymore. You can see it's not even. One side is higher than the other, one side's lower than the other. So balance means we want these two sides to be even. If we have 10 grams over here, we need to have an equivalent or equal amount on the other side. To get that, if we're adding 1 gram at a time, you would need 10 of those to get to 10 grams. Part B. Next, Isaiah puts a 100-gram weight on a pan balance. How many 10-gram weights does he need to balance the scale? So if I have a value of 100 over here, I'm going to add 10-gram weights until I get to 100 on the other side. That's how I keep that balanced. So let's start adding our 10s till we get to 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. How many 10-gram weights did it take? It took 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It took 10 of the 10-gram weights. So right here, if we look, to go from 10 grams to 100 grams, we had to multiply 10 times 10. 10 tens is 100. Looking at part C, Isaiah then put a kilogram weight. Kilo is going to mean 1,000, so this is a 1,000-gram weight on a pan balance. So over here he has 1,000 pounds on the pan balance. How many 100-gram weights does he need to balance the scale? To balance the scale, we're going to start putting 100-gram weights until we get to a total of 1,000 pounds. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. It took 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 100-gram weights to balance out the 1,000 grams on the other side. 10 100-gram weights brought us to 1,000 total grams. If we look back at that chart at the top, we can see that if we have 100 grams, 10 times 100 grams, that gives us 1,000 kilograms. And if we look at part D, it says, and I love this part, what pattern do you notice in parts A through C? I'm looking at all of my answers, and all of them are 10. Let me go back and look at this chart up here. We said on problem 1 that to balance out the 10-gram weight, we needed 10 of the 1-gram weights. 1 gram 10 times is 10 grams. Then we said we need 10 of the 10-gram weights to give us 100 grams. 100 grams 10 times would give us 1,000 grams. I'm starting to notice a pattern, and I'm sure my third grade friends are too. Every time we move to the left on this chart, we're multiplying the number that came before by 10 to get to our new destination. 1 times 10 is 10. 10 times 10 is 100. 100 times 10 is 1,000. We said a kilogram is 1,000 grams. This is moving us into, kind of ever so gently, into the understanding of the base 10 place value system that we use. And we'll get more into that during place value, but there's a times 10 relationship as you move places from right to left on our place value system, as you move from the ones to the tens place, the tens to the hundreds, hundreds to the thousands. You're going to notice that we do it in groups of 10, which is why when we get 10 ones, we bundle them and move them to the tens place. That's something that's going to come as we get more into the place value part of this module, which we will probably start looking at in the next week or so, would be my assumption, by the time we get through some of this beginning measurement stuff. So that's it for this page 56. If you have any questions, please feel free to reach out. I'll be happy to help you in any way that I can. Thank you.